Hi, so if you are watching this, we're just looking at some questions with kinematic equations. And in the side pad there is a question about two boats having a race. So we have boat A and boat B. They're in the same race. Boat A has an initial velocity of 0, so it starts off stationary, accelerates at 4 meters per second, and the distance that these boats are racing is 800 meters. So for boat B, it's in the same race, so it's got the same distance. It had a running start of 12 meters per second, and as it crossed the finish line, it was going 52 meters per second. So the question that is posed is, which boat wins? And for that, you need to think about, which boat is going to do this race in the minimum amount of time. So we need to solve the time it takes this boat to do this and the time it takes boat B to do this. But we have different information for each boat. So we have to think, well, if I want to find T, I need to look for a kinematic equation that has these four things in it. Or I look for the kinematic equation that does not have VF in it, because I don't have VF. So it'll be this one. All I can do is substitute in my values that I know and solve it for T, and it should spit out a number for me. So you can choose to rearrange the equation first if you want to, that's fine. But I like to put numbers in first, so 800. Vi is 0, so 0 times time would just cancel that whole part out, and that's quite convenient for us because then it just leaves us with half 80 squared. So half, and your calculator looks like that, times A times T squared. Half of 4 is 2, so 800 equals 2 times T squared. 800 divided by 2 is 400. And to undo that square, we're going to do a square root. The square root of 400 is 20. So that's how long it takes boat A to do this race. Boat B, we have different information. We have VI, VF, and D. So we don't have acceleration. So if we want to find out the time, we need to use a kinematic equation that does not have A in it. But it's this one. So again, it's inserting our numbers that we have, 800 meters. Everything is already in meters and meters per second for us, which is convenient. VI plus VF is going to be 12 plus 52, so that's 64 divided by 2. So 64 divided by 2 is 32. I'm just going to go straight in for it, times time. So that means that 800 over 32 is what the time is. In your calculator, that will be 25 seconds. So which boat wins the race? The boat that does the race in the minimum amount of time. So boat A will win the race. Remember not just to do the calculations, but actually to have a sentence. Boat B wins the race because it makes the race in the minimum amount of time. All right, so that's information now that we know about each of these boats. Another question in this iPad about these boats was for you to calculate the acceleration of boat B. So you could use, now that we have T, you could use T, but if you've made a mistake calculating this and then you therefore use the wrong value for T, that's going to mess up your answer. So I would prefer to use the values that I'm given in the question. So I have VI, VF, and D. I want to calculate A. So I need a kinematic equation that does not have T in it. So I'll use this one to calculate the acceleration of boat B. So we'll go in purple for this one. boat B, VF was 52. VI was 12. Plus 2. Acceleration is what we're trying to find out. And then distance was 800. This is all kind of together. 52 squared, I believe, is 2704. 12 squared is 144. 2 times 800, 1600, and then times A. Taking your numbers on the one side and leaving A by itself. That's going to come down, well, and if you wanted to, you can actually just divide that by 1600 there. Do that all in your calculator, and that will leave you with A. So 1.6, if you do that in your calculator, is what the acceleration of boat B is. So most people found that okay. If you used time as 2.5 seconds here, you should have come out with the same acceleration. So no matter what kinematic equation you use, the answer should still be the same. All right, put our kinematic equations back in the pile. The next and final question was the trickiest, and it's really strange. It says calculate the time at which both boats are moving with the same velocity during the race, and it also does say to state that velocity. So we have to also say what that speed will be. This takes a lot of consideration, but what you want to do is use information that we've already got from boat A and boat B to calculate the final velocity of those boats. But you have to consider that boat A has a velocity, and it's going to be the same as the velocity of boat B. We can calculate the velocity of boat A. We could go VI of boat A plus A and T of boat A. T is what we're trying to find out, so that's going to be the thing we solve. So VI for boat A plus A of boat A times time is going to give us this. That would also be equal to doing all of this for boat B. So we could put, okay, that's all going to be equal to doing that same equation, but for boat B's information. So that is the hardest part to come down to, because you have to kind of be able to say, okay, I want to calculate this, this is how I do it. It's got to be the same for both boats. So I'm just going to do that for boat A, that for boat B, and they should come out to be the same number. So that's what we have to do. So using the information, I've got it here, so I'll tell you what it is. We're just going to substitute numbers in. So VI of boat A was 0. A for boat A was 4 meters per second squared. And T is what we actually need to find out at what point in time this is happening. VI of boat B was 12, plus its acceleration, which we calculated before, of 1.6, and time. So now we just have to solve this for T. What is T going to be? So it's going to be 4T, take away 1.6T, because that's all like one thing, right? And that's all one thing. And then you learn that when you're in like year 10 algebra, yeah? That you can take those away from each other, will equal 12. So what's that, 2.4 is going to equal 12. 2.4 T's equals 12. So that means time is going to equal 12 over 2.4, 5 seconds is our answer. That is the time in the race at which both boats are moving at the same velocity. We don't know what that velocity is, but we know that it'll happen at the 5 second point. So what we could do is take any information for any boat. We'd have to take it just from the one boat though. Could take all this information, whack in time equals 5 seconds, and then we can solve that for the final velocity. So finishing off this question, okay, at 5 seconds, both boats at the same VF. What is that VF? Well, we know that we can calculate VF if we have the initial, the acceleration, and the time. So if I do that for boat A, doesn't matter, it would come out if I did it with boat B as well. The VF at the 5 second mark for boat A is going to be, boat A had a 0 initial velocity, which is nice, had an acceleration of 4, and the time was at the 5 second mark. There we go. So that is the final velocity that boat would be going at the 5 second mark. And so then for boat B, it would be the same. If you want me to just go through it with you, boat B had a VF equals, its initial was 12. Its acceleration was, we calculated before, 1.6. And again, the time was 5 seconds. So 1.6 times 5 plus 12. Well, yeah, so 8 plus 12, 20 meters per second. Yay! Hope that helps. And that is that question that we've just done with the, what the same velocity, what time is that? That's an excellence question, right? So it just takes lots of practice, and it just takes a lot of being familiar with what you are able to do with kinematic equations. Thanks for watching.